everyone, this is our first video for SM015 Chapter 1 Number System, subtopic Real Number. Alright, to get a clear view about number system, let's go through this information that is also available on YouTube. Okay, let us focusing on this video.
The number system. Today we are going to learn about natural numbers, whole numbers, integers, rational and irrational numbers. So let's jump right in. A long time ago, man uses finger or marking on bones for counting and later devised various symbols or figure for each number, while in those times, man normally counted the animal killed and ate. Several thousand years later, man still counting, although mostly money. Counting comes us naturally, something that goes 1, 2, 3, 4 and so on. Hence, such numbers are grouped as natural numbers with the symbol N. Well, you may be rich one day, but there are days when you are flat broke with no money left. So many come to describe a notion of nothing number 0 was discovered. When we did add the number 0 to the set of natural numbers, we get what is called as the whole numbers. Symbol W. In most circumstances, these are the number we deal with. Nothing more and nothing less, except of course certain situation proves this to be not true. For example, when you have to measure the depth of ship below sea level, when the temperature drops to sub-zero underway the chilly condition, and of course when you owe money to the bank. In all such cases, the number are called as negative number, which when clubbed together with whole numbers, formally you grouped called integers, strangely denoted by letter Z. So far so good. However, there are situations when you require to deal with parts of whole or fractions as they are called. For example, parts of pizza, measuring height of more accurately, in this case 1.5 meter, calculating the fraction of difference of time in a very close race, specifies measure of ingredients in a cake's recipe and so on. So any and every number that you can practically think of, any number in real world which can be denoted as a fraction or in a decimal form constitute as what is called real numbers. Expertise symbol R. Now take any integer, say -4. This number can be denoted as a fraction, namely -4 by 1. So all integers are real number too, as obviously are the whole numbers and the natural number as well. Here are some examples of real numbers. On the number line, we have 3 by 2, which is 1.5, minus 1 by 3, which is 0.3333. Just keep repeating the decimal digit. The number 6 and 18 by 5, etc. Now, most of real decimal numbers can be expressed as form of ratio. What is meant by this is that the number can be returned as the ratio of two integers. Of course, denominator cannot be 0. For example, 0.4 can be written as ratio 2 by 5. Minus 0.375 is minus 3 by 8. Also, 2.33, where decimal 3 repeating forever can be expressed as 7 by 3. So the number can be expressed as the ratio of integers, where the decimal terminate or repeat are called rational numbers. On the other hand, there are some number that are irrational or not rational. Try dividing circumference of circle by diameter. The answer reads something like, and it goes on forever. The calculation never terminates, nor shows any repeating pattern of any sort. This is the number pi, also written as 22 by 7. But this ratio is just an approximation, not accurate. Another example of irrational number is under root 2, which is the length of the diagonal square of size 1 unit. But this number also does not terminate, nor do its decimal repeat certain pattern. Numbers like these are irrational numbers, which have many applications in the real world, by the way. Example being calculating area or volume of shapes that involve circle. Encryption algorithm. There are in compound interests on loans by banks, etc. So number that cannot be represented as ratio of integers and where decimals do not terminate nor show any repeating pattern are called irrational numbers. Both rational and irrational numbers form real number, as can you see here.
So that's it for real number. Please don't take it lightly because it is very important for you to know each type of number. Okay? Now we are going to learn about so the video that we already watched already summarized everything from page 1 until page 2. Okay, so it's already summarized everything. Let's go to an interval of real number. Alright, so we have special video as well for this, and this subsequent video will give us a thorough explanation on how to represent each type of interval on the number line. So, enjoy!
Hello, I'm Professor von Schmohawk and welcome to YU. In the previous lecture, we saw how to create bounded intervals using either set builder notation or interval notation. We saw that if an interval includes both its endpoints, the interval is said to be closed. In interval notation, included endpoints are enclosed in square brackets. Intervals which do not include their endpoints are said to be open. Excluded endpoints are enclosed in parentheses. It is also possible for one endpoint to be included and the other excluded. If the left endpoint is included or excluded, the interval is said to be left closed or left open. And if the right endpoint is included or excluded, the interval is right closed or right open. Bounded intervals are also called finite intervals since their endpoints limit them to a finite length on the number line. Endpoints create bounds for an interval, in the same way that a fence creates a boundary for a plot of land. Just as an interval may or may not include its endpoints, a plot of land may or may not include a fence which creates its boundary. However, whether or not a plot of land includes the fence which creates its boundary, it is still bounded by the fence and therefore limited to a finite area. Likewise, whether or not an interval includes its endpoints, those endpoints bound the interval to a finite length on the number line. So left and right endpoints act as lower and upper bounds for the numbers in an interval. No number contained in an interval is less than its lower bound, or greater than its upper bound. In a closed interval, the left endpoint is the minimum, or smallest number in the interval, and the right endpoint is the maximum, or largest number in the interval. However, since an open interval does not contain its endpoints, open intervals have no minimum or maximum element. To see why, let's take a closer look at an open interval. This interval's right endpoint is the number 1. However, since 1 is not included in the interval, in order to find the maximum number in this interval, we must find the largest number less than 1. If we pick 0.9 as the maximum number, we know that this is incorrect, since 0.99 is larger, but still smaller than 1. But this number is still not the largest because 0.999 is larger. But this is still not the maximum since 0.9999 is larger. No matter how many nines we keep tacking on, we will never reach a maximum number in the interval. No matter which number we pick, there will always be a number closer to 1. The fact is that there is no maximum number in an open interval. This same logic explains why it is also impossible to find a minimum number in an open interval. However, regardless of whether an interval's endpoints are included or excluded, they still bound the interval to a finite length on the number line. But what if an interval has no upper or lower bound? There are 3 types of unbounded intervals. If an interval has no upper bound, we say that the interval is right unbounded. In interval notation, this is indicated by replacing the right endpoint with an infinity symbol. In set builder notation, this is a set of all x such that x is greater than or equal to -1. If an interval has no lower bound, we say that the interval is left unbounded. This is indicated by replacing the left endpoint with a negative infinity symbol. This is the set of all x such that x is less than or equal to 1. And if an interval has neither an upper nor lower bound, we say that the interval is unbounded on both ends. This interval therefore includes the entire number line and is equal to the set of real numbers. In interval notation, an infinity symbol is always enclosed with a left or right paren. This is because the infinity symbol does not represent a number. It is a symbol which indicates that the interval goes on forever in the positive or negative direction. We therefore use the parentheses to indicate that the infinity symbol is not a member of the set. All the intervals we have discussed so far are proper intervals because they include more than one point. However, it is possible for an interval to include only one point or no points. In the next lecture, we will explore these degenerate intervals as well as sets which contain multiple intervals.
So that's it. To make sure you understand the content of the video, you can try to complete example 1 by yourself. This is example 1. Okay, so basically the video that we already watched summarize everything in this table here. So now, please complete example 1 by yourself. Discuss about union and intersection on intervals. Okay, so for union and intersection here, the symbol for union is this, A union B. Alright, also it can be read as OR, this one OR. Intersection here denoted by A intersect B, and it can be read as N. Okay, that's for union, that's for intersection. Alright, so how to simplify each of the following for example 2? Let's go through example 2A first. Okay, so first and foremost, when we come across this kind of question, you need to draw a number line. Okay, let's draw a number line first. Draw a number line, and we will arrange the number involved in ascending order. So what's the number involved? We have -3, we have number 0, 1, and 4, somewhere here. And then, if open interval, then the circle is empty circle, right? So here, -3 until 4, empty circle. -3 until 4, empty circle. Okay? And, meaning intersect. Intersect, symbol for intersect meaning and. Okay, we can read as n. And number 0 until 1. So it empty circle as well because open interval. And then what should we find? If it is intersect, then we need to find where's the two lines intersect with each other. Okay, so where's the two lines intersect each other? This is the line. So we just, we just shade the region here. So that's it. That is the region where the two lines intersect with each other. So from there, what's the number involved? From number 0 until 1, right? So what about the interval? Is it open interval or closed interval? Obviously, open interval. So the answer is open interval from number 0 until number 1. Very, very simple. Right? Okay, now let's go to B. Example 2B. I'm sure you can finish it within 1 minute. Okay, example 2B. So the same thing here. We draw a number line first. Okay, draw a number line. What's the number involved? We have -1. Please arrange in ascending order. We have number 1, -1, number 4, and lastly number 10. Okay, so what we can see here, that's the symbol involved less than equal to. If there is equal to, meaning it's closed or open interval. Obviously, it's a closed interval. So closed interval meaning the circle must be dense circle, right? Meaning dotted. It's not empty circle, it's dense circle. So, -1 until 10, please draw the line where -1 until 10. Dense circle. Why dense circle? Because close bracket, close interval. Yes, let's play with the color. Okay. So from -1 until 10, that's how you should draw the line. Okay. I'm not talking about the colorful here. It's just that the dotted dense circle and then straight line. And then from 4 until 10. Okay, now let's draw number line from 4 until 10. So 4. Here you can see the symbol. Is there any? So, x less than equal to 10, greater than 4. Greater than 4. Okay, greater than 4. So, it's just greater than. Meaning the circle is just empty circle. And 10. Okay, 10's then circle because there is symbol equal to that. So, from these two lines, we are talking about union. Okay, we are talking about union. So, what's the difference between union and intersect? For union, we will shade the region whenever there is a line. So we can see here that our line involved from -1 until 10. So that is where our shaded region should be. Right? So that is the difference between intersection and union. For intersect, we will shade the region where two lines intersect with each other, whereas for union, whenever there is line in that our number line, we will just shade the region. So the answer here, what's our answer? From -1 until 10. Okay, 10 there. It is a closed interval because dense circle. Okay, very simple. Now let's go to a bit complicated one. It's not that complicated, just a bit complicated, which is example F. So we go to example F. X greater than equal to 4 or x less than equal to 2. intersect with x less than equal to 6 greater than equal to 0. So please draw the same thing. Draw a number line first, whatever it is, draw a number line. Okay, what's the number involved? We have number 0 arranged in ascending order. We have number 2. And then we have number 4. Last one, we have number 6. Okay, x greater than equal to 4. Okay, x greater than equal to 4. So how should we draw our number line? X greater than equal to 4, like this. Meaning there is no end point, so it will go straight until infinity. So that's our number line should be. That's how is it. Or x less than equal to 2. Okay, then draw a number line for x less than equal to 2. X that less than equal to 2. Okay, that's it. And or meaning union, right? Union. For union, we need to shade the region where our number line is. So if we don't want to confuse, okay, please shade the region first for our first question. So this is the region. Because or there, whenever there is our line, that's the region should be. And then intersect with number line that satisfies the law x less than equal to 6 greater than equal to 0. Then I want to use a different color. Okay, x less than equal to 6 greater than equal to 0. Okay. This is it. That's the line, right? From 0 until 6 and then circle because equal to, the symbol of equal to. Okay, now we are talking about our question here, one intercept, right? For intercept, meaning we need to find the region where our lines intersect with each other. So where is the region where our lines intersect with each other? I'm sure you can see it obviously, right, from our drawing. So this is the region. Am I right? So let's shade it again. Okay, so what's the answer, class? So the answer should be from 0 to 2. Okay, and it obviously involves close bracket because of the dense circle. From 0 until 2, union from 4 until 6, close circle as well, because everything here involves dense circle. So that's the final answer now. That's it. Hello everyone. Now we are on our lecture note 1 of 3, which is involving indices, sets and logarithm. But for this video, we just are going to focusing on indices only. Okay, so rules of indices actually make solving complex problems involving power a lot much easier. So basically, there are 4 rules of indices that we need to know, which is for multiplying, dividing, and raising power to a power, and also negative index. So we just need to focusing on this one. Okay, multiplying, dividing, raise a power to a power, and negative index. Okay, for multiply, when we multiply indices, we just need to add the power together. When we multiply, this one is multiply, right? So when we multiply, we add the power together. And when we divide, this is divide, right? Operation here is divide. We need to minus the power. If the base is dividing, so the power need to be subtract. Okay, and for a power is raised to a power, meaning we have power here, 2 to the power of x is raised to the power of 2, then the index must be multiplying with each other. Okay, we need to multiply the index together. Alright, so we have two different examples here. Either 2 to the power of x is raised to the power of 2, or 2x is raised to the power of 2. It's different, okay? So for this, we need to multiply everything inside here by to the power of 2. Okay, it become like this. And then solve 2 to the power of 2 is equal to 4. So the answer will become 4x squared. Okay. So here is different, okay? Now, what about zero index? Is very simple, meaning anything to the power of 0 will become 1. So why it become 1? I need you to explore it by yourself and explain to your friends. Make sure they can understand. Now we go to negative index. A negative index means the base, the base must be moved to the denominators. Why? Because when there is a sign changes, if there is a sign changes here, then we need to cross the line here, negative m, right? So normally a to the power of m. So if negative m involve change of sign, we need to cross the line. It will become 1 to the power of a to the power of 1 over a to the power of m. When there is negative index, we move the base to the denominator. The base is a. So a here will be moved to the denominator, a to the power of m. Move to the denominator. Okay. Now let's go to example 4. So I hope that you can clearly see or clearly remember all the rules of indices involving that's very important, okay? Now let's go to example 4, because example 3 you need to solve it by yourself. We go to example 4. Okay, so first and foremost, for the first example, A. Simplify each of the following expressions, meaning we need to simplify the question until it's very simple, meaning we cannot simplify it anymore. So here we have 3 to the power of 5 multiplied by 3 to the power of 6 over 3 to the power of 4. So first and foremost, is the question have the same base? Yes, the same base here, because involving 3, everything is 3. And then for this one, we solve the numerator first. Okay, the numerator first. So we have 3 to the power of 5 multiplied by 3 to the power of 6. If multiply, we need to add the power, right? So we have 3 to the power of 5 plus 6 over 3 to the power of 4. Okay, so we just plus the index here because multiply. The base is multiply with each other. Now involving divide. So if the base dividing, meaning the index dividing with each other, we need to subtract the power. So it will become 3 to the power of 5 plus 6 minus 4. So what's the answer, class? It will become 3 to the power of 7. Okay, that's the answer. Okay, it's a very simple example. Now we go to example B. For example B, okay, to make the... So first and foremost, we must make sure is the number that the question give is in the simplest base. No, right? Because we know for 49, if we multiply 7, multiply by 7, we'll get 49. Okay, so meaning the lowest index for 49, the lowest base for 49 is 7. So here we solve first. It will become, sorry. So it will become 7 square x square y to the power of negative 4 raised to the power of half. Okay, 7 square x square y to the power of negative 4. Now it is in the lowest base, which is 7. So what can we do next? Okay, there is different different integer involving here, different things. There are 3 elements here in this bracket itself. We have number 7, we have x and y. So what can we do? We separate all the things there, meaning we try to solve one by one. 7 square, okay, to the power of half. And then we have x square to the power of half, and y to the power of negative 4 is raised to the power of half. Okay, solve one by one. So now 7 square become, okay, so this one becomes 7. Why? Because here, okay, becomes 7 here. And then become 1. And this one, negative 4 dividing by 2, you will get negative 2 here, okay? So it will become 7x y to the power of negative 2. But that's not the final answer yet. Try to, if there is negative sign, okay, make it in the form of fraction. So for the final answer, we have 7x over y square. So that's the final answer. Can you follow? I hope you can. If you cannot follow, then please rewind this video over and over again until you can understand. Okay? Thank you. Now I hope that's enough for B. Now we go to question C. So when you see the question, please make sure that it is in the very simplest base. So now it's not in the simplest base, right? For C, we have 4, 8, and 16. What's the base? The simplest base for all 3? Yes, 2. 4, we have 2 to the power of... Okay, now we go straight away to the base. The simplest base is 2 to the power of 2 to the power of n divided by... For 8, we have 2 to the power of 3. Yes, to the power of 3 become 8. If you're not sure, please use your calculator. For 16, we have 2 to the power of 4. Okay. And then, for this one, power raised to a power, we just multiply the power. It will become 2n divided by, for this one, it become 2 to the power of 2 and multiply by 2 to the power of n. So now if divide, we minus the power. If multiply, we plus the power, right? And if the operation here involving divide and multiplying only, we just need to solve from left to right. Okay, so divide, we minus the power, become 2n minus 2n plus n. So what's the answer? Yay, the answer is 2 to the power of n only. So that's the simplest form. We cannot simplify it anymore. Okay. Now we go to the last question, which is question D. So for this question, this is a bit trickier, but try to follow as much as you can. So for this question, how to solve this? What can we see here? We know that there is 2 to the power of 2 and here also we have kind of same thing, 2 to the power of n. So okay, we have 2 to the power of 2 and here, okay, 2 to the power of 2 and 2 to the power of 2n as well here. So the idea is we need to simplify it in the power of 2 to the power of 2n. Okay, try to simplify first. Okay, how? We have I'm sorry about that. Okay, so we have here 2 to the power of 2n. Okay, dot here means multiply by 2 to the power of 4. That's why it will become to the power of 2n plus 4, because multiply you need to plus the index. Okay, so here 24 dot, okay, 2 to the power of 2n, 2 to the power of 2n minus 2 to the power of 2, right? Okay, dividing by 10, 2 to the power of 2n. Okay, so okay, we cannot, okay, what can we solve? We can solve this here. This one is actually, okay, multiply. Okay, what can we see? We know that each term have 2 to the power of 2n. So we can actually remove this. Okay, because each term have 2 to the power of 2n. So what is left if we subtract this? I mean, we omit these 3 terms here. I mean, all the same thing. So we omit this. What do we have left? We have 2 to the power of 4. 2 to the power of 4 minus 24. We have negative here. 24. Okay, 2 to the power of negative 4 meaning it will become 1 over 4, right? 1 over 4. Okay, dividing by 10. So this one become 4. This one become 6. So 2 to the power of 8 and 2 to the power of 4 is 16. Minus 6 divided by 10. So we have 10 dividing 10 will become 1. So this is the trickiest part, but I'm sure you have no problem with it. Okay, thank you, class.